All right, so welcome to chapter number 5, classes. Classes themselves are the foundation of object-oriented programming, and Java is an object-oriented programming language. Not to say that all languages follow the OOP methodology, but most of the popular ones these days actually do in one way or another. So Java, C++, Python, JavaScript, geez, the list actually goes on. Rust. They all follow the object-oriented concept. What is object-oriented? Well, the idea is that you have a class definition, and a class definition describes uh, how how data and actions, so attributes, which are eventually what we call data for classes, and actions, which are the methods. A class itself can't be used on its own, except for very special circumstances, but you must create an instance of it, and the instance is called an object. So we've seen that before with strings from the very first thing we've ever done in programming. So the string itself is a class definition, and from that you create instances of strings. So we create the name string, or we create the output string. We create any string that is required. All strings will have different data, of course, they contain different string characters, but they all have the same methods. They all do the same thing. So that's what classes and objects really are. But object-oriented programming has these three things: encapsulation, polymorphism, and inheritance. That's what makes it an object-oriented programming language, if you support these three things. Some languages only support maybe the first two, encapsulation and polymorphism, but they don't support the third one. By that definition, it is not an object-oriented programming language. So C, as example, does encapsulation in a way. It does polymorphism, actually probably where the idea came from, but it doesn't actually do inheritance, which we'll talk about much later. So C itself is not an object-oriented programming language. C++ is. It does all three. Java is. JavaScript is. It does all three of these. So we're going to take a look at actually only the first two in this course. Inheritance, we're going to leave for the next course, actually for the rest of your programming career. But we're going to look at the first two. So encapsulation is the idea of grouping together, as it says, things that belong together. So if we look at the string class combines together string stuff. So it's characters, that's the data for a string. It even has a length, that's another piece of data. The methods themselves, you can ask a string its length. You can ask a string to return its characters in uppercase or lowercase, or a substring. There's some actions. You can ask a string to compare itself against another string. These are string-specific actions. Strings don't do math. They don't know anything about input or output to files. Strings only do string stuff. They encapsulate the idea of being a string. So the scanner class for input and output, the scanner class does just that, input. It doesn't do output. It doesn't give you the length of a string. It doesn't do any mathematics. It only does input. So the scanner class itself encapsulates scanner ideas. Polymorphism is a way where a class can provide different ways of looking at some of the data that it has or performing some of the actions. But polymorphism isn't really to stick within the class. Polymorphism is a way to look at different classes that sort of act very similar to each other. So a way of this would be to look at the string class and maybe the scanner class. You can actually ask objects of the string class and objects of the scanner class to display themselves. Now, what does that mean for a string? Well, for a string, it means to maybe just return its characters. But for a scanner class, what does it mean to display itself? Well, for a scanner class, if you ask it to do that, it's actually going to return the characteristics of what makes it a scanner. So what input stream it's connected to, maybe what language it's using, what locale, so is it English, is it Chinese, what language, so it's sort of interesting what polymorphism really implies. What we're going to look at is the method view of polymorphism, which means we can actually give methods very similar names, if in a way exactly the same name, but they perform different actions based on how you call them. So we can look at the substring class the substring method for the string class. Substring, you can call it with one parameter, and it basically goes to that particular index and then to the end of the string. So it gives you a part of that string. But you can also call substring with two parameters, a starting index point and an ending index point. And it gives you a substring between those. So it doesn't go to the end of the string. So the substring method has two ways of calling it. That's polymorphism, which literally means many faces. And that's a way to just be super lazy and you say, you know what? I just want to call it substring. I'm not going to call it substring A and substring B. I'm just going to call it substring and we'll let another programmer figure it out. But polymorphism has many different ways to look at it, almost because its name implies that. So we're going to start off looking at just methods. It's the most entertaining way of looking at object-oriented programming, and it's probably the oldest way to do this idea of encapsulation. We save a lot of time by putting things into methods that are a bunch of repeated actions. So how do we write methods? Well, let me skip ahead here in the notes, and we're going to write our method. So I've just skipped over a lot of stuff that is class definitions. We're going to go back to that. So what is a method itself? Well, we've looked at methods when it's systemout.println, systemout.print, math.min, math.max. Those are all methods. So the end part, the .max, the .min, the .print, .println, .printf. For the scanner class, you've got scan.nextInt, so the .nextInt, .next, .nextLine. All those dot things. At the end, that's the method name. That's how Java knows I'm going to go over into the program code and run this particular set of instructions. Now, generally speaking, for everything we've seen so far, we don't actually write any of those methods. We're using the string class itself, and we're just asking the string object, give me your length, or give me your two uppercase, or give me your two lowercase, or ask if you're equal to another string. We don't know how those methods actually carry out those actions. And that's one of the encapsulation hallmarks of methods. They hide those actions. You don't know how they need to execute it. You just need to know one particular thing. How do you call it? So we're looking at this example of something called calc. So calc is the name of the method. That's how you call it. So it's going to be, just calc. It'll be similar to println. What is the name of this thing? How do you call it? What's in the parentheses is very similar to the .printf or .println. It's what do you give this method for it to accomplish what it needs to accomplish? Some methods don't have any parameters. So for example, the scan.nextInt, you don't give it anything. It's supposed to return back to you. So the nextInt takes no parameters. Print, on the other hand, you can pass into it a string, you can pass into it an integer or a char, or practically anything. Or don't pass anything. And if you don't give anything to print or println, pretty much nothing shows up on the screen, except println puts a new line. So every method does its own special thing. So for the example that we see on the screen, we see calc is the name of the method, and it takes three parameters, or three arguments. Argument, parameter, there are proper terms for it, but in this day and age, they pretty much mean the same thing. So we've got first an integer, we're going to call it num1, a second integer, we're going to call num2, and a string, we're going to call message. So when you call this method, it actually will take two integers and a string. So you can think of it like the flexibility. These are variables. The method doesn't know what these values are going to be. It doesn't really have any idea. These are going to be local variables just to that method. If you think of the main method, so it also has some parameters. We call that the string args. That's something that's given to main. We're going to look at that as a special case. Main is a very, very, very special purposed method. So what do you do with this method? Let's see. So here's the method definition. So for calc. So you give it the two integers, num1, num2, and you give it a message, which is a string. And what it's going to do is take the two numbers, it's going to add them together. It's then going to use that number to calculate which character in the message string to return back. Return back, what does that mean? Well, methods themselves are useful in two ways. One is to carry out special instructions, and the other one is to, after those instructions have been completed, if there is a result to return, it can actually return it. And in this case, we actually call that variable result, and it happens to be a char. So what is this method going to do? It's going to get called in with a number, another number. It's going to add those two together. Those actually become the index. So we're calling it sum, but it's really just the index into the string that we're going to use for char at. And it's going to you get a character in that message string, return it into result, and then that gets returned as well. Now, this is just the method definition, but where is it useful? So let's skip ahead here. And let's write a method that does something. So I'm going to write a very simple program here. So public class method tester, public static void main string args. So there's actually the beginning of our main method. So we've actually been writing methods since the very first day. Huh, interesting. So save some space here, and that's the end of our program. So I'll just call it method tester, and we'll do a quick compile just to make sure my compile is working, and perfect. All right, so let's use something similar to the calc method. So what it's going to do is it's going to get some information, process it, and then return a particular value. Let's do something really, really simple. We'll just call this method, call it string length. Now, methods themselves require a few things. Number one is a very clear name. So this method, we're going to call it string length. Now it's going to perform exactly the same thing as the .length method for a string. But let's just do some magic, because this will be very simple and it should be very, very clear. So we're going to give it a string. So let's see, call this one, let's see, bumblebees. There's our string. What it's going to do is return the length. So I'm going to store that in a variable. So length 0, and let's see, length there. So get the length of the string, and we'll just display it to the screen. There we go. So we're just displaying the length of the string. So this method has never existed before. This method is brand new, which we have to define. So in our class called method tester, we currently have one method, and that's the main method. But I'm introducing a brand new one called string length. Where do I have to define it? Well, it's going to be a sibling to the main method, which means it has to follow all the same rules that the main method will, well, at least for this particular class. So it's going to be a public method, it's going to be a static method, and we'll talk about static soon. We also need to know the return type, so I'm going to leave that one blank for right now. It's going to be called string length. That way Java needs to know where to find it. And it now needs the particular parameter. Now you'll notice up here, the parameter was a string. So we'd better actually tell the string length method that it's going to get a string. And we'll call this one str. I can call it anything I want, but I'm going to call it str. Now, it's supposed to return back the length. So in here, I'm going to declare another variable, call it length of string, just to be different than the length variable we have up above in the main. So I'll just give it a 0 there. So length of string is going to be assigned the value of str.length. So this will be the length. Now, a lot of repeated code, but that's only because the string itself has its own length method. And now I'm going to return the length. So return length of string. There we go. So let's compile this. And what's it missing? Oh, it's missing the return type. So a method itself, as I mentioned, can perform different actions. Now this one takes in a string, which we call string length, and it determines the length of that string, so it gets it from the string itself, stores it in a variable, which we called length of string, and then it returns the value. But what does that value get returned to? Well, go up here to the method of where we called it. There's the assignment symbol, which means that this method here, string.length, is supposed to return something. It'll be a value, and it hopefully is the same value as whatever this variable is. Now this variable is an integer, so this string length had better return some sort of integer, and that's this spot right here. It's the return type of the string. So if we go back over to the notes, we had the return value. So if we looked at the method itself, let's look at this one over here. So the method was called calc. It took three parameters, an integer, and a string, but it returned a value called char, or a data type of char. That is the purpose of this method. So it encapsulates the idea of taking in two integer values, using those to figure out the index position of that string for the particular character it needs to grab and return it. So this method encapsulates that single message.charat action, and it hides it away. So anybody using the calc method doesn't really know how it works, but they know that if they give it two values, two integer values in a string, they're going to get the character of those two integer values added together as the index into the string. So if we look at our program, or our method called string.length, we pass it in a string. That's going to be called str for the method itself. And it's going to then determine the length of the string by actually asking the string itself. So we're encapsulating that action, and it returns back the length. And it returns it as an integer. So that's an integer. The length of string variable is an integer. The return value here is of that integer. That integer is then assigned to the integer in the main method. A lot of variables here, a lot of integers going on. But let's compile this. Should be working fine. And we should have the length of the string is 12, because that's how many characters there are in bumblebees. Now it seems like a lot of work. Couldn't we have just asked for the length of the string up here? Well, yes, we could. But what if I wanted to do two strings? So see how many instructions this string length method has. It declares a local variable called length of string. It calculates the length of the string by asking the string itself, and it returns a value. So if I wanted to carry out this action again, so let's copy this, we'll put it down here, and let's see, let's do another one. My name is Billy Bob. So we've got that string. So let's compile this guy, and let's run it. And there we go. We've determined the length of both of those strings. Beautiful thing about this is that there's the method right there. It's called for bumblebees. We display the length, and then we call the same method again for my name is Billy Bob. But we're calling the same method. Same when you do systemout.print or .println, use math.min or math.max or any method. The method itself doesn't know which data you're going to use until you actually call it. So in this case, we're calling it with bumblebees as the very first example. So that string gets moved over here. It's called str locally just to the string length method. The string length method has its own variable here called length of string, which is assigned the value of the length of that string, and it returns it. That value is then assigned to len up here. We then call the same method. So the method gets started. The my name is Billy Bob string gets tossed in here. So that's what string is referring to. We create again the length of string, and then we get the length of that particular string, and we return it, and that then is stored to len, and that's what is displayed. So you can see that by encapsulating the actions of string length, we can call it as many, many times as we wanted to, and it doesn't matter for which string it is. Same with systemout.print or .println. We don't know how those actions work, but we can just call them over and over and over again. So let's take a look at another method, which will be slightly different. This one is going to add three numbers together, and it's going to return the average. So let me remove all this, and let's keep this method in here. Beautiful thing about methods is they can have them carry in a file. You don't need to use them, but you don't need to delete them. So as long as the method is there when you need it, you can actually use it. So this method we'll call public static. Let's see, it's going to sum three integers together. So it's going to return an integer, which is the sum. We'll call it sum integers. That's funny. Let's see, int. Let's see, we'll call it val1, int val2, and int val3. So this method has to get passed in three individual integers. And what it's going to do is add them together. So let's see, the sum is going to be a val1 plus val2 plus val3. And we're going to return the sum value. Excellent. So let's go up here and actually calculate it. So we're going to, let's see, declare, I'll call it total up here. So total of the sum of 1, 2, and 3. So that should give us 6. So we'll just display it. What do I have? The name of the method. It's called sum integers. And now we will run it. Excellent. So we got the value of 6. So sum integers itself takes in three values, 1, 2, and 3, becomes val1, val2, and val3. We add those three together, and then we return that value. Methods themselves are actually much simpler than you'd think they are. The idea of methods is to encapsulate instructions. Similar instructions that you could do up in the main method, but if you repeat them over and over and over again, you would end up with a lot of code. So let's add a characteristic to this method. We're going to make sure that it's the average. I think I mentioned that. So we'll call this one the average. So I'm going to change its name. And this one will, of course, we'll call AVG for average. Change the name here to average. Excellent. So now to calculate the average, of course, we need to calculate the average. So that's going to be the sum divided by 3. Now there's a problem here, of course. If you calculate the average of something, especially integers, you might get an integer back, or you might get a floating point. So we're going to make a call here, and we're going to say, you know what? This will return maybe some double value. I don't want to lose any precision. So I'm going to change the average to a double. And to make sure I don't lose any precision, I'm going to introduce a double value here, and I'm going to return back the average. But we're not done. So what I'm going to do is leave it like this. You've probably seen where the problem might be, but I'm going to leave it just like this. And I'm going to try and compile it, and we should get an error. And here's one of our errors. We don't have anything called total. That is called AVG. Let's try one more compile. That's the error I was hoping for. So in this case, what's Java complaining about? possible lossy conversion from double to int. Well, the method itself is called average. It has 3 integers, adds them all up, figures out the average, and returns the average. But take a look at the data type. Average is a double, but we're telling the average method that it's an integer. Java has a problem returning this value here, which is a double, as an integer. So we have to change that to a double as well. Now, of course, we have one more error that we'll have to deal with, but that'll be in the main method. And let's compile that. And there's our second error. So this one's telling us again the same problem, conversion of double to int. But in this case, average itself as a method returns back a double. But we've said, please take that double and store it to average here. So I'm going to take that, convert it to a double. So now we have a method called average, which gets 3 values as integers, adds them all up, figures out the average. No loss of precision though, we're storing into a double, and then we return the double up here, and then we display it. So let's compile and run that. So now we have the average of 2.0, which is correct. Now there's a couple of things about methods that we have to remember. So let me go into this over here, and we're going to, let's see, I'm going to add a new slide in here. So a new slide, and let's see. So a method itself, things you need to know about the method. Number 1, name. The name of the method. It should describe what it does. I mean, math.min, systemout.println, terrible names for methods, calling it X. Not a very good method. You can use all the identifier rules that we have, so upper, lowercase characters, and the underline, but the name of the method should conform to what its purpose is. The parameter list. The parameter list is important in terms of the order of values. Now, it doesn't mean that there actually is an order. If we go back over here and we look at our method, which has 3 integers, they're all integers, but the order matters in terms of the first value being 1, that goes to value 1, the 2 goes to value 2, and the value 3 goes to value 3. If we had a string parameter, that might change the order. We would have to make sure that it's at the end. I'll go through an example of just that in a moment. So the order of values matters, and that's how Java determines the method itself. We're going to look at that rule in just a second. The last one is the return type. So the return type is what is actually getting returned by that method. So those are the aspects of the methods. The most important thing about this is that only the name and parameter list are used by Java to identify the method. This is called the method header. So whenever we're referring to something called the method header, that's actually what it is. So if we look at our program over here, the method header is the name of the method called average and the list of those values. The return type is not used by Java to find the method itself. It doesn't actually know what the return type is until it needs it. And so it's very similar to the right-hand side, left-hand side. If we look at the call, average up here, Java first has to evaluate the average of 1, 2, 3. It doesn't actually know what the value is getting returned to. So I mean, it does actually know that it's a double. The compiler will figure that out. But when it's trying to find which method to call, it looks through this whole program and it says, I need to find something called average. So it finds something called average. And then it says, okay, found it. Does it match the parameter list? So the parameters are being called are an integer, and an integer. And it sees here, I've got 3 integers. Perfect. This is the method and I need to call, and it goes ahead and calculates it. How important is this? Well, let's write an additional method here. So I'm going to call this one, let's see, figure out average. We'll use the same variable called average. We'll call another method here called average. And in this case, I'm only going to have 2 parameters. Not 3, but 2. And let's display this. So we're displaying the average again. Let me try and compile it, and we'll see what Java says. It's an interesting error. So it's saying here, method average in class cannot be applied to the given types. So it sees the method called average. So it sees this method. It sees that it requires an integer, and an integer. So it sees that that method needs 3 integers. But it only found 2 integers, the 2 and the 4. So it says, you know what? This method is not the one that I'm looking for. The argument list or the parameter list is different. Therefore, this isn't the method I'm looking for. So we need to write another method because this one is supposed to calculate the average of only 2 values. So for this, I'm going to write a brand new one. So let's see, we're going to do the same actions. Now in this case, we're calculating an average of only 2 values. Therefore, we're going to divide by 2, and we're going to return average. Excellent. So now let's compile it. Hey, Java didn't encounter an error. So for the very first example up here, it found the method we're looking for called average with three parameter values or 3 arguments. Perfect, they're all integers. This one, average with 2 integers. It found it for this call over here. So excellent. Let's go ahead and run it. And there we go. So for the first one, the average is 2, which is correct. And for this one, the average of 2 and 4 is 3, which is the middle value. Perfect. Now, you might be looking at this and wondering, I've got 2 methods called average. Interesting. Well, you know what? Now you've seen an example of polymorphism. So we have 2 methods called average. They seem to perform the same function, which is to calculate an average, but each one has a different parameter list. And that's actually something very special. Java doesn't know that these two have the same name from a programming point of view. It actually calls them something different after it compiles them. But when we're looking at the code, we see the name average. For us, we need to then decide which one we want to call. So we use the argument list. So that's what Java is doing as well. In order to figure out which of these methods to call, it uses the name of the method and the parameter list to figure out that method. The return type, not so important. So let's modify this program a bit. So let's change the second average program. Instead of returning back a double, to return back an integer. So we'll change that to an integer. We'll do some, there we go. So now this should be okay up here because Java should be able to take that integer and actually transform it into a double automatically. So this will use the integer to double automatic promotion. So that's not going to cause a problem. So let's run this, and there we go. Java found it appropriately. The return type actually doesn't really matter. It found the name of the method. So to also prove that the return type doesn't matter, If I copy this method and paste it down here and just change this to a double and to a double and change it back to what it was before. So now we have three methods. We have the first one up here, which has name of the method called average, three integers in the parameter list. We have another one called average, which has two integers. Another one which has also got two integers, except this one returns back a double. If we look up here in the program, the average with two integers, how will Java be able to tell which method to call? It won't know what the return type means until it actually gets a value to assign over here to the left-hand side. So it can't actually use the return type to distinguish. The only things it needs to know about the method header is the name of the method and the two integers. So if we try and compile this, we should get an error that this is already defined. So there's already something called average with two integers. You'll notice that the data type does not even show up in the error. Java does not care about it, not part of the method header. So let's add another note here. So the method name describes what it does. If the same method name is used, this is polymorphism. But for polymorphism to work properly, the parameter list must be different. So with polymorphism, the parameter list is different. So if the two methods have the same name, they had better have a different parameter list. That's very special. Now, let's get back to looking at the variables themselves. So I'm going to clean this up a little bit. I'm going to remove that and remove the next two methods. And let's see, in this case, what about all these variables? We've got average and average and average. So many averages going on. Let's rename this one to average. Average and average and average. So many averages. And they compile and it runs. And how is this possible? So Java has what are called scope rules. So scope rules. Let's add that note in here. So an identifier is defined within the bounds of the scope it belongs to. What does that mean? Well, let's take a look at average. So we do have an average up here in the main method, and this is a regular double variable. It's called average. So in the memory map, Java is actually going to carve out a special place for the main method, and it's going to put the average variable in there as a simple primitive. Over here in the average method, there's going to be another piece of memory carved out, and Java is actually going to put this method there. It's going to call it average. Now, within the method itself, very similar to within the main method, so the memory for that average method, it's going to have its own thing called average itself. So this can get very complicated. Let's draw this guy out. So I'm going to introduce another slide here. We'll get rid of everything on this slide. And let me just add in some shapes. So we'll add this one and this one. So we'll call this one the average method. We'll call this one over here the main method, and the main method itself actually has within it the average variable, and then the average method also has its own average variable. And then surrounding all of this is the program class. So this is our big old program class right here. So let's add a little note there. So that's the memory for the whole program class. Within that, the main method itself exists, and then in this one, the average method exists. Now the thing about the average method, it doesn't always exist. It's only there whenever it gets called. So I'm going to change the shape a little bit. So we'll give it a no fill, actually a solid fill there. We'll give it a white. Terrible color, terrible color. That one's better. So the main method, of course, always exists. The average method really doesn't always exist. It's only there when it gets called. Now, if we look back at our program, this is the first reason of explaining what static is. Static itself defines anything that always exists and there's only one copy of it. So when we have our program, it immediately runs, the main method is created, so is the average method, but the average method isn't completely filled out. It will only get fully executed and fully filled out when it gets called. The main method is immediately created because that's the purpose of this class, is to run that main method. So the main method gets run. If we look back at our program here, main method is run. It gets something called len, which we're not using anymore. It then creates this double variable called average, and it tries to assign it something. So now it has to figure out the right-hand side. Here's where it creates average. So average itself gets called. Now our average has val1, val2, and val3. So it's actually got those variables as well. So it's got the average variable. It's also got the parameter list. So parameters, val1, val2, and val3. So those get created as well. Those are local to the average method. The average variable, val1, val2, and val3 are all local to the average method. So it goes ahead and actually does the calculation. So it adds those to, oh, I forgot about sum. So sum is in there as well. So we've got the sum variable. Forgot about that guy. So we've got these three, sum and the average, and then we return the average. So when the average method is finished, that average value will actually store the average calculation, and it will get returned over here as an assignment. As that is happening, the average method is collapsed. It's garbage collected. Now, it's still there in memory, but the actual values here, the average variable, the sum variable, and val1, val2, val3, they all disappear. For all practical purposes, their values are gone. And then that value is then assigned to the average up here. So even though we have multiple average values and we have an average method, Java isn't actually confused because this average variable belongs to the main method, this average variable belongs to the average method, and the average method is just a method. So Java knows that that itself is not a variable. So by calling it in this syntax. And this is why it's very important to know your parentheses, your braces, your brackets, and so on. This is how Java is determining that that's actually supposed to be a method by those parameters. Now it's a lot to hit you up with just the methods themselves. But I'm going to stop the video for right now, And in the next one, we're going to look at more examples of methods. We'll look at some polymorphism as well and how to make methods efficient. All right,